So starting on the 2.12 notes, what we're working with today is logarithmic function manipulation. And basically the long story short of this is we're learning different properties with logarithms, how we can expand them, how we can condense them, and just some of the different properties that allow us to do so. So hopping straight into it here, we have three properties. I'd highlight all of them. Like you have the product property, the quotient property, and the power property. The product property basically says that multiplication, like if you multiply, you can go back and forth between addition. And with this, what this looks like is log base 2 of 5x. In my argument on the example, that's saying 5 times x. So I can break it into, you will notice that I have the same log base on both. I can break it apart into two separate log base 2s. And then I'll take the 5 here and the x here. So log base 2 of 5x can be broken up into log base 2 of 5 plus log base 2 of x. And the important thing is I can go both ways. So if I had the right side first, log base 2 of 5 plus log base 2 of x, I could also go to log base 2 of 5x. Same thing with quotient properties. What quotient property is, you're going between division, subtraction. And one thing I will notice is right here, whatever is in the numerator goes first and whatever is in the denominator goes second. So on this example, log base 3 of y over 4, I can break that apart by saying the same log base, so log base 3 for both. Log base 3 of the numerator, so y, and then log base minus log base 3 of the denominator, 4. And then for the power property, you can think of this as front to the exponent. Like you can go back and forth between the front and the exponent. Here's what I mean. If I have this example here, log base 7 of 3 to the x, I can move this exponent to the front and rewrite it. Or if I have it like here, I can move what's in front to the exponent. And one thing I will say is I think this makes a lot more sense when you look at it with actual examples. So let's do that. So for each of the following, write an equivalent expression by condensing. If you've already started on the Delta Math homework, you'll notice that there's kind of two ways. You can go by making it as small as possible, condensing. I would highlight condensing there. Or you're going to expand. You're going to make it smaller, or you're going to expand to make it bigger. You can go either way. So to condense these, what you're going to do is look at what do I have. Okay, I've got addition. So that means I'm going to change it to multiplication. And I'm going to always try to condense it to a single logarithm. So the base stays the same. And then I'm going to multiply my arguments. So x times y. Pretty simple there. On B, it's subtraction. And if I look at my chart above, subtraction goes to division. So I can write it as log base 3 of 5 over z. And then for C, I can look here, and what I have is two subtractions, okay? This is something we've not looked at yet. Basically, what I would say is take care of any addition first, and then all of the subtractions go on bottom. All subtracted terms go to denominator. So all the subtracted terms will go to the denominator when I divide. So I'm going to start by writing this log base 10 of x. X is on top, then minus 5. So 5 is on bottom, and then minus z. So z is on bottom. Now for this one, we're going to use the other log rule, the power rule, first. And what I'm going to do here is, when you're doing these, always, I would say move exponents sorry, let me rephrase that. Take care of the front first. It's going to make your life a lot easier. Take care of the front first. So what do I mean by that? I can move the 3 that's in front to the exponent of my argument. So I'd have log base 2 of x to the third minus log base 2 of y. Because the reason why I'm doing that is this and this have to match. Right now, like before, that 3 there, it doesn't match. Like, it's 3 times log 2, but now I've got log 2 and log 2. So when I look at this then, I can rewrite this with division now. Sorry, I've got log base 2, x to the third is going to be on top and y on bottom. Same thing with all of these. I'm going to move the fronts first. Log base 7 of a squared minus log base 7 of b to the 5th plus log base 7 4. Now just go in order here. I would highly recommend to do addition first. So this is a positive one and this is addition. I'm going to do addition first because you can add and subtract in any order, right? I'm going to take care of the addition part first. So log base 7 of, and when I add, I multiply. So I'm going to multiply a squared times 4. So 4a squared minus log base 7. And then I can rewrite it as log base 7 of 4a squared over b to the 5th. And the last one here, I've got 2 plus log base 6 of x. And the weird thing here is I've got to rewrite this in terms of log base 6 because this and this need to match. So I'm thinking, okay, so the answer is 2. And I know I've got to have log base 6, but what has to be right here? So basically it's saying 6 squared is what? So I could rewrite this as log base 6 of 36. That's what? I'll highlight that. I'm using this to rewrite that one. Okay. And then I've got the other one plus log base 6 of x, which can be rewritten by multiplying as log base 36 6. So once again, I know it might have been a little bit confusing, but if I just have a number here, I can think of rewriting it as what that representative log was, because 2 is the exponent. Remember, logs are bay, so b a e. So it's saying 6 to the 2 power is what? If I'm going to rewrite it for the argument there. Example 2. Which of the following expressions is equal to this? So this is just like a multiple choice practice problem. I'm going to rewrite this. And now, this is an example of expanding. We're going the other way. It condenses one log, and you can see on all my answer choices here, I'm going to multiple logs. So remember, division can be broken up as subtraction. So log base 3 of x squared minus log base 3 of y. And now, to rewrite this fully, when you expand, you can do the power rule the opposite way. You can move the 2 to the front. So you would have 2 log base 3 of x minus log base 3 of y, which would be, let's see, example 3. The function, okay, I will say on example 3, this is a lot more wordy than what it really is. Like, it's it makes it seem a lot harder than what it really is. The function f of x equals log of 6x is a horizontal dilation of the function g of x equals log of x. Show that f can also be written as a vertical translation of g, with f of x equals g of x plus k, where k is a constant. So what this means, okay, use your log rules. Use log rules. And let's write out how it wants it. It wants us to show that f of x is equal to g of x plus a number k. This is just, remember this k here is just some number. It's a constant. So what that means is I can rewrite f of x, which is log of 6x, using my exponent rules, my multiplication rule, sorry, the product rule. I can rewrite this as log base x plus log of 6, log of x plus log of 6. And now when I look at this, log of x, that's a function. And you might think that kind of looks like a function, but the thing is, this is just going to output a number. So if I go to my calculator and I type in log of 6, that's just 0.78 approximately. So what we've done here, you wouldn't show this step, but you could rewrite this to make it make sense to yourself. You would stop here, but you could also rewrite it as this. So log base 6, you can, I'm trying to think of the best way to explain this. You could think of this as log of 6x is log of x shifted up by about 0.78, which is that vertical translation piece that they were talking about. Now, when we are doing the change of base property, this states that for any log like this, I can rewrite the log with any base as long as I have it matching. And then when the base matches, I can rewrite it as the argument on top and the base on bottom. The way I would remember this is base on bottom. The base goes on bottom. So I can rewrite it in any way as long as I write it with base on bottom. So we can use that. Let's do an example before we start. So let's rewrite just an arbitrary one. Log of lit of swag. Log base lit of swag. Okay. And then we can choose a random word. Here, I'll get a random word. Laren, give me a random word.
Popcorn.
Popcorn. Okay. We're going to use it on the notes. This is how simple it is. So if I want to do log base popcorn on both, as long as I use the same base on these, log base popcorn, the base goes on bottom, so the argument of the bottom, and then the argument stays on top as the argument here. Okay, and that just shows you that you can do it with any words that you want or any numbers that you want. So let's see it with a numerical example. Let f of x equal log base 4 of x and g of x equals log base 9 of x. Show that f is a vertical translation by writing it in this form. So f of x is equal to k times g of x. Okay, so let's write out what they want. F of x equals k times g of x. And then I could rewrite this as log base 4 of x, because that's what f of x is. And g of x is equal to log base 9 of x. Now, I want this to be like f of x is, so I'm going to use log base 4 on top and bottom. Okay, so to change the base, I can rewrite this as log base 4, to rewrite log base 9 of x. So remember, the base stays on bottom, log base 4 of 9, and then log base 4 of x. Okay. So that's what I'm showing, is that all that I have when I rewrite this is going to be, I can move this out front, 1 over this, so 1 over log base 4 of 9 times log times the top log base 4 of x. Okay, so because remember, this is a number, which I'll show you here. Was it log base 4 of 9? Yep. Math. Log base 4. Oh, it's actually, let's make it a fraction. 1 over log base 4 of 9. About 0.63 approximately. So what you would leave it like this, but you could also say that g of x is just 0.63 times log base 4 of x. And then the last part, we have the logarithm with base e as just the natural log. Log e is the same thing as ln of x. So to rewrite some of these, you would do the same exact rules, okay? I could rewrite it using the same rules. So here, I would just move this to the exponent first. So ln of x to the third minus ln of y to the fourth. And how do I rewrite subtraction as division? X to the third over y to the fourth, which is why the answer would be A. But before we're done here, I know the note's in here, but I want to do another example of one that might look a little bit weird. Let me see. Let's expand this one. So ln of e squared x to the fifth. And remember, e is a number here. E is the number e. Over square root of z. Okay? So, let's break this apart piece by piece. I can break this apart as ln of e squared minus, plus ln of x to the fifth, because this top breaks into addition, and then everything on bottom is subtraction, so minus ln. And remember, the square root of z is the same thing as z to the 1/2. So I'm going to go ahead and rewrite that as an exponent because it works out nice. Z to the 1/2. Okay. Move the exponents to the front. If I'm expanding, to ln of e plus 5 ln x minus 1/2 ln of z. And notice here, you're mostly simplified, like these are. What I would go ahead and do though is ln and e are inverses. So these are going to cancel out. So I can simplify this to 2 plus 5 ln of x minus 1/2 ln of z. And to show you what I mean with ln and z e canceling out, let's go ahead and type that in my calculator just to prove it. So 2 ln, and then e can be found, let me see. Second divide, yep. Because ln of e, 2 ln of e is just going to give me 2. But what if I just put this, like what if I delete this part? Ln of e just cancels out. So that's how you would rewrite that one.